Hey everybody, this is 2B, force and acceleration. So it says Angela's standing on a very low friction skateboard while Blake pushes her away from the motion detector, which is set to record velocity as a function of time. In trial 1, Blake pushes softly. In trial 2, Blake pushes harder. And in trial 3, Blake pushes Angela the hardest. So they give us a graph here in part A, and so it says here, use the data provided by the motion detector to find a pattern between the change in Angela's motion and the interaction with Blake. Fill in the blanks. So remember, trial 1 was the soft push, trial 2 was the harder push, and trial 3 was the hardest push here. So we can see that we get more and more of a slope the harder and harder the push, but all of them level out at some point there. So let's fill in the blanks right here. It says when Blake pushes harder, the slope of the velocity versus time line increases. So we can see that clearly on here. Since the slope, and I'm going to have to abbreviate in here to fit it, equals acceleration, right? A velocity versus time graph, the slope is acceleration. So since the slope equals acceleration, the acceleration is increasing. More slope, more acceleration. It says when Blake stops pushing, the slope of the velocity versus time line becomes 0. Since the slope is now 0, this means that the acceleration is also 0. So no more acceleration after Blake stops pushing there. Okay, let's go to part B. So in part B it says, the students repeat the experiment. This time, Angela's holding 2 textbooks and then 4 textbooks. Sketch the diagram of the velocity versus time for Angela with 2 and then 4 textbooks. Blake pushes with the same force. That's very important every time. So the velocity of Angela without textbooks is already sketched there. So remember in Newton's second law here, we know that the acceleration is the net force over the mass, so we can just say this, acceleration is proportional to 1 over the mass, or in other words, acceleration is inversely proportional to mass. So then when we go to make these lines here, if we increase our mass, that will decrease our acceleration. So if this is no textbooks, let's say 2 textbooks increases the mass, so less acceleration, which on this graph means less slope, because the slope is acceleration. Just like all the other ones though, once you are done pushing, then you will cease to have acceleration, and therefore you won't have any slope. So that, for example, would be 2 textbooks. So our mass goes up. Now, how much down does it move? Well, we don't know that. We would need to know, you might say like 2, versus 4, but we don't know how much mass Angela had to begin with and how much the textbooks contribute to that. We do know, however, once again, because acceleration is inversely proportional to mass, if we up the mass even more by 2 more textbooks, then we will lower the acceleration even more. So we will have less acceleration, which on this graph means less of a slope there. And so our line will have less of a slope, and then, just like all the other ones, wherever we were, our line will stop accelerating from that point on there. So last part here, part C, it says, the following statement is written to describe what will happen after the first 5 seconds when Blake is no longer pushing. Cross out any incorrect statements and explain why they are incorrect, and use the checklist to help you. And so it says, after Blake stops pushing Angela, Angela will travel at a constant speed for a few seconds before she runs out of force. So you do not run out of force. So she will go at a constant speed, but this part right here is not correct. Then she will decelerate and stop. This is also not correct. Now let's explain why that is. So you can say a few things on this. There's 2 different approaches you can take. You can do it from the first law. So according to the first law, if there's no net force, then motion is uniform. So if we don't have any outside forces, then she won't slow down and stop. She'll continue on in a straight line. So you could also take it then from the second law as well. From the second law, you could say, according to the second law, since A equals the sum of the forces over the mass, sorry, my sigma's really messy there, if the sum of the forces equals 0, then acceleration equals 0. So no acceleration means that she won't speed up or slow down. She'll stay going the same speed there. So this checklist over here, what this is training you for is to write the paragraph length response on the AP exam. So they're just telling you to make sure when you write that paragraph that you answer them directly, don't beat around the bush, that you state a law of physics that's always true, like the first law of motion or Newton's second law of motion, that you connected the laws specific to the situation. So you should be clear here, right, that once Blake is no longer pushing, there's no net force. So you may actually feel the need to talk about how if Angela's on this skateboard here, that there's no net force, so maybe there's a normal force up and there's the force of gravity down, but there's no net force. There's no longer a push to the side anymore. So that might connect it a bit better to this situation. And you use physics vocabulary, force, mass, acceleration, we used all of those, so we are good.